Hey everybody, and welcome to another exciting JASP tutorial. What we're going to talk about this time is how to do a paired sample t-test. Where we last left off, we did a one sample t-test. Very similar. We're just going to do a paired sample one now. Just a little bit about the data set before we analyze it. This is imaginary data. What I have here is the participant. So it's going to go from from 1 to 100. Baseline, I am imagining that I'm giving them a memory drug and I'm looking at their working memory scores. So I'm looking at how many items they can store at once, I know that the population mean for that should be about 7 items, plus or minus 2. So we're going to be testing people. That gives us, how many items in a list they can remember. And then we're going to give them a treatment. So we're going to give them some kind of miracle pill that is going to increase their memory, hopefully. And then we're also going to test them with a placebo that does not do anything. And then we're going to test their memory again. So if I'm doing a paired sample t-test, I'm going to be looking at before and after, right? So I'm going to be looking at whether or not treatment had an effect on baseline or whether or not placebo had an effect on baseline. So we can evaluate both of those things here. So you're going to go to t-test and you're going to go to paired sample t-test. And now what you want to do is you want to add to the variable pairs section what your combinations of interest are. So I am interested in looking at baseline versus treatment. And so you can either drag these across or you can insert them in right there. And I'm also interested in baseline versus placebo. Okay, so that's all you got to do. You're already done. Look how fast you are. I'm so proud of you. So if you're looking at this, the way to interpret this is that we have baseline versus treatment and baseline versus placebo. And you'll note that that usually, honestly, we probably want to have these flipped just because it's a little bit more interpretable. But just to show you what I mean is, like, for example, we have a t obtained value of -7. And what that means is that, for the most part, the average is lower than baseline. But that's not what we want, right? We actually want to swap these around. And that looks better. So what we're saying here is that it actually does increase, the treatment does increase memory, and that placebo doesn't. How do we know? Because we can look at the p-values over here. The p-value is less than 0.05. So we're going to say that treatment does reliably increase memory for this example. And for this one, that the placebo does not reliably affect memory. So we're going to reject the null hypothesis for the first one, and we're going to fail to reject it for the second one. And that's pretty much it. So that's pretty easy. But if I am interested in changing my alternative hypotheses, I will imagine that my hypothesis is actually that that treatment is going to be higher than baseline. So you can change that in JASP. It's not going to change our output because we had such a high t value as it was. But if you wanted to, you could do that there. You can check for normality over here. I can see here that data is mostly normal, and that's because it's simulated data. Or actually, it says that it's not completely normal, but that's fine. This is imaginary data. If you want to look at descriptives, and I always do, I like to hit descriptives just to look at the means for each of these, because that helps me interpret the data a little bit better. So I can see here how many people were in the groups, I can see what the individual means were, and so you can see that, basically they improved by like 1. Like they were able to remember about 1 item more. So that's fine, probably not a huge effect size, but that's okay. And we can actually look at the effect size. What is the effect size? So the effect size here, the treatment, the effect size is moderate for the treatment, and it is non-existent for the placebo, which is exactly what you would expect. I think that's pretty much it. The things that we want to talk about. If you want to use a confidence interval, it's best to use that with a with the non-directional hypothesis. Again, what you're going to expect is that if 0 falls within this confidence, then you cannot reject the null. But as we see, 0 does not fall within this first up here for the treatment, so we can reject the null. Here for the placebo, you can see that 0 does fall between these two values, and so we cannot reject the null. All right, I think that's pretty much it. So I think it's pretty much straightforward. If you have any questions, let me know. Otherwise, I will see you in the next tutorial where we talk about independent samples t-tests. Bye.